Before we get started, I do this thing. I usually always have a selfie stick, but I don't, so we're going to have to see how long my short arms are. But everyone has to get in the picture and give me your best smile. Okay, ready? 1, 2, 3. We're going to do one more because my finger was in it. Awesome. All right, cool. That was your first and probably only assignment. The rest of it is optional. So welcome to my talk, DevOps with Kubernetes and Helm. How many people in the room are already using Kubernetes? How many people in the room do not know what Kubernetes is? Perfect. This is the perfect talk for you. I'm guessing I already know the answer to this. How many people have ever heard of Helm? How many people are using Helm? All right, perfect. This is also the talk for you. And for everyone who didn't raise their hand because they're too embarrassed, this is still the talk for you. My name is Jessica Deen. I am a cloud developer advocate for Microsoft. Let's get the questions out of the way first. Yes, I do use a Mac. Yes, Microsoft gives me Mac. They actually have given me 2. No, I have not been set on fire for using a Mac or touching an iPhone, which is where I took your selfie picture. I actually have more Apple certifications than I do Windows or Microsoft certifications. I don't even know what they're called. My background primarily was Linux, open source, DevOps, and containers. So I spent years before joining Microsoft as a Linux system administrator. I am here because, frankly, I love technology and I love community. I love working with communities. I love talking to people. I just love showing people cool ways to do things that they didn't know how to do. I also love Disney and CrossFit, so if you follow me on Twitter, chances are you'll possibly see me upside down doing like a handstand push-up or something, which was yesterday's tweet. And then you can also find me on all major social networks, GitHub, Twitter, Instagram, LinkedIn, at JLDeen. No relation to James Dean, so there's 2 E's in my spelling. Disclaimer. Have to go through this because we only have 30 minutes and there's a lot of information we're going to have to cover. The next 30 minutes, as much as I would love to, is not going to make you an expert. Sorry. But it is intended to get you thinking. It's going to show you what's possible with these tools we'll talk about, and it's going to give you even some sample code for you to get started on your own time. That's that optional homework I talked about. So first, let's talk about the state of technology that we're in. We are going digital. Some might argue that we have gone digital, right? We have so many new devices, so many young companies that are starting up. These are studies that were done by various business journal reviews and Gartner. According to a study that Gartner did, they estimated that by 2020, 1 million devices per hour would be coming online. That's a year and a half away. They estimated by that same year, the average age of an S&P 500 corporation would be 12 years of age. Compare that to the 1960s, where the average age was 60 years old. Right? We're having more and more companies start up at a rapid pace and more devices coming online. It was also estimated that 60% of computing would be done in the public cloud by 2025. That's 7 years away. And we're already seeing such a shift to the cloud where you have Google, Amazon, Microsoft, all of us are going kind of all in on this cloud shift. So how, as systems administrators, or some that now are kind of bridging that gap between sysadmin IT to kind of like development with this infrastructure as code stuff. How do we meet this demand? First, we have to listen to both our developers, the ones that we're supporting, and then we also listen to our fellow IT. Here's what we're hearing from developers. That I want to be able to move fast, right? I need to be able to create applications at a competitive rate without worrying about IT. I don't want IT to become the bottleneck. When I give you the application, you being operations, the application runs smoothly on my dev system, but it hits your server and now it's broken. It's your problem. And then we also hear that my productivity and my application innovation becomes suspended when I have to wait on you. Again, IT becomes the bottleneck. That's the dev perspective. And regardless of whether or not we agree with it, we have to hear it so we can know how we can adjust to it. But here's our perspective, being in IT or systems administration. I have to minimize risk, right? I can't just give you access to my servers to run your application and say, go wild, go nuts. I also, because I'm not a developer, don't know how to run your unfamiliar application and integrate it with my infrastructure. I have to work with you. And then also, I can't handle both infrastructure stuff and handle the application operations. I can't worry about my security and your application security. So that creates this need for DevOps, right? We have to work together. Because then we have what's called IT stress points. And I don't only use IT in the reference to operations or system administration. This is anyone who works in technology. If you touch software, if you touch infrastructure, if you touch architecture, these are our stress points. We have to worry about security. We have to worry about efficiency. And we have to support this innovation that we just talked about. So that's why the cloud is important. Cloud is a new way to think about data center, right? We have our traditional model where you have dedicated infrastructure for each application and each project. Your hardware is purpose-built for that project. Your infrastructure and operations teams are distinct and separated. I often use an analogy where it's like a sixth grade dance. You have people on one side of the room, people on the other side of the room, this awkward empty space in the middle, right? That's the traditional way. And then even the processes and configurations you would use are customized for that mindset, for that culture. But cloud, you now have these loosely coupled apps and microservices. We don't have giant monolithic applications that are taking 6 months to update anymore, because now we have just little bits and pieces we can move and update and roll forward or roll back. The hardware we're using is now industry standard, right? That's a benefit of cloud. And then the teams that we have to deliver service are DevOps-focused service teams. That's why DevOps is so popular. And then we have processes and configurations that are now standardized rather than customized. So that's kind of, it gives you the new way to think about it. But that sets up the conversation for DevOps. So DevOps is a 3-stage conversation. I'm assuming since we're at a DevOps conference, everyone has kind of already heard this definition. So I'm going to move through this a little quickly so we could get to the fun stuff. But DevOps essentially has 3 parts: people, process, and products. And the definition we stand behind is DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. If we're not delivering value, what are we doing? So we stand up architecture, we stand up infrastructure, we have gold masters and images of systems, and we hand them off to our developers or people at our company. But how do we know that it's actually what they need or what's going to support this innovation? If it's not delivering value, if it's not streamlining or simplifying their experience, how is it going to ultimately get down to our customers? And I have to say, something popped up on my screen. Of course, that's super helpful in the middle of the talk. All right, now standard DevOps practices. Everyone in the room, I'm sure, has already heard of some of these. Infrastructure as code, continuous integration, continuous deployment, automated testing, release management, performance monitoring, availability monitoring, load testing, autoscale, and even automated recovery. A lot of these are practices that we as systems administration or IT can use to help monitor our servers, our infrastructure, and even down to our developers' applications so we can give them metrics and telemetry that they can take and use in their next sprint. Benefits of implementing DevOps. This was a study, Puppet does this each year from 2015 to 2016, 2017. When you implement DevOps, you're able to deploy code significantly faster. Your lead time for changes also increases and becomes faster, and your mean time to recover becomes faster. Even your change failure rate becomes lower. Now, some of these numbers, there's certain gaps in year over year, but that's because all the measures are relative, right? They compare the difference between high and low performers, and you can't just take it at face value. Some of them, high performers are still shipping code as the business demands, but low performers went from shipping maybe 6 months to once a year to now shipping once a month or once a week. So DevOps as a whole, and this innovation that we've talked about, sets up the stage for containers. Why are containers or cloud or any of this, why is it important? Well, first off, we talked about both developer problems and IT problems. For developers, it enables this write once, run anywhere kind of world. It enables microservice architecture, and it's great for dev test applications and services. And even Helm that we'll talk about, it's great to test infrastructure and architecture that our developer might not understand. It now empowers them to be able to test their application with the architecture all at the same time. And from an operations standpoint, from our standpoint, it's portable. We now can have standardized developments, whether that's QA, whether that's dev, whether that's staging, or even prod. It's all going to be standardized. We don't have to worry about one server differing from another server, differing from another server. We're also able to abstract differences in operating system distribution and underlying infrastructure. Now, what is a container? Since I know some people in the room said that they're new to Kubernetes, they don't even know what it is. When I first started delivering this talk, everyone's like, that's awesome, Kubernetes sounds great. What's a container? It meant I wasn't very effective. So I always like to throw this in. First off, a container is not a real thing. It is an application delivery mechanism with process isolation, and it's based on several Linux kernel features. So keywords that you'll hear in the Kubernetes container world is you'll hear namespaces, which is what a process can see. It's also like a little kind of grouping where you can store all your resources for your deployment. And then C groups is what a process can use. That's things like your hardware, right? That's your memory, your CPU, your devices. Now, what is Docker? We're talking about Kubernetes, but how does Docker tie into it? Because you will hear Docker. Docker is an open source container runtime. It is cross-platform, so you can use it on Mac, Linux, or Windows. In the edge version of Docker, you can actually even run a Kubernetes cluster. So I don't have to do anything I'm talking about today in the cloud. If I want to run Kubernetes on my MacBook, just the very simple 8 gigabytes of RAM small MacBook, which I have a Kubernetes cluster running on it. I don't have to do it in the cloud. And then I can use the tools we'll talk about with Kubernetes through Docker. It's a command line tool. There's also something that's called the Docker file format. It's a layered file system format that you use to build images that you then deploy for your containers to Kubernetes. So here's an example of what that layered file system looks like. You have a base image right here, in this case Ubuntu, and then you have all these read-only layers that get cached as it's building the image, and it kind of gets flattened. That's what you define as part of your Docker file. And then the container layer, where the application and any app dependencies where this is running, all the read-writes go on top of that layer. Now, I use a CI/CD tool to demo Helm Kubernetes. It's a tool called CodeFresh. This is an example of an actual Docker file being built from CodeFresh. So you can see all the different layers, even down to whatever I labeled it, exposing a port, running a command, doing an environment variable capture, specifying another environment variable for go path, and so on and so forth. Each one of those layers gets captured and bottled up, and then they're read-only and flattened, meaning that I can't go back and edit it once I have this image. But I can use that image and use the application to call parts like environment variables, and we'll see that in a demo. Now let's talk about virtualization versus containerization. First off, I'm sure people in the room familiar with the old school concept of virtualization, right? There's two primary types. One, you can have your hypervisor sitting directly on top of hardware. Think of that like VMware. And then you can also have your hardware with the host operating system, and then your hypervisor sitting on top of the host. Coming from Microsoft's world, that could be like Windows Server with Hyper-V. Now with containers, which is over here, containerization, you have your hardware, you have your host, you have the Docker engine that kind of sits on top of it, and then you have any dependencies for the system, and your containers kind of sit on top of that layer. And the container, since it's process isolation, you have your application dependencies and your application all encapsulated. That means the runtime environment is completely encapsulated. And Helm is going to take that one step further, where you also can tie in your infrastructure and have that as part of your package and your source control as well. Advantages of using containers. We've talked about problems for both developers and IT. So advantages for developers, you now have fast iteration, so we've removed that bottleneck. You have agile delivery, and it's immutable. I can move it around. I don't have to worry about, it works on my system, but it doesn't work on your server. And for IT, there's cost savings. I'm no longer having to run around from a time performance perspective, trying to manage all these different servers or all these different computers and wonder why it's working over here and not over there. I'm now able to have efficient and reliable deployment, and it's even elastic bursting. If I were to run these tools, say in a private environment, in a private cloud, or a private data center, but based on CPU or hardware demand, I had to burst into the public cloud, I can do that with these kinds of tools, with container orchestrators. So now let's specifically talk about Kubernetes, which is why everyone's here. First off, what is a Kubernetes? Or what is Kubernetes? It is an open source container orchestrator that automates deployment, scaling, and management of applications. It has some basic features. You'll notice how some of these features kind of tie back over to the DevOps practices we talked about earlier. But the key points I want to highlight, and I know we're moving fast, again, it's a short window of time. Key points I want to highlight is it was designed by Google. It's based on their system that is used to run billions of containers per week. There are over 2,300 contributors, including Microsoft, Google, Red Hat, IBM. Major companies are part of this contributor upstream. And it was also, as of March of this year, the first and only project as of this date to have graduated from the Cloud Native Foundation. There's more about the graduation requirements online. Now, the next question I get asked is, okay, Kubernetes sounds really cool, but it's still new. By the way, it was developed initially and released back in 2015. It's about back in 2014, sorry. But it's about 3.5, almost 4 years old now. So who's using it? Is it really ready for production? There's a handful of small companies. Not sure if you've heard of them. Small companies like Twitter, Twilio, Spotify, very small. You have Bloomberg, you have Box, Capital One, some other smaller companies like Pokemon Go, Ticketmaster, right? It is ready for production, which is why so many people are wanting to know what Kubernetes is, how do I use it, what are best practices. This talk, or a version of this talk, is probably my most requested talk to give because we're adopting it at such a rapid pace. So now let's talk about Azure Kubernetes Service, which is the cloud. You can run this on your computer, and there's pros and cons to doing that. One pro would be that you want to get familiar with Kubernetes and you don't want to go out to the cloud while you learn it. That's applicable. But if you do want to get started with the cloud, we have AKS. What is AKS? It is your Kubernetes cluster managed by Azure. It is the fastest path to Kubernetes on Azure. You can get up and running with 3 simple commands. I like to argue it's technically 2.5. You can do automated patches and upgrades. You can easily scale the cluster up and down. It's a self-healing control plane because we manage it, and it uses open APIs. It is 100% upstream Kubernetes. This is not a Microsoft forked version that we took off and went off on a different branch and put our Microsoft magic juju on it. We're a primary contributor to Kubernetes, and this is full upstream. This is a slide you'll probably want to take a picture of. This is how easy it is to get started. When I say 3 commands, I mean 3 commands. If you already have kubectl installed on your system, the second command, this is optional. You don't have to run that every time. So that's why I said I argue there's 2.5. The first command will create your cluster. The second command is going to create the authentication for your computer to talk to your cluster. Then this is just interacting with your cluster. The second command is managing it. So I can manage it. You'll notice, by the way, this is using Azure CLI. Again, it's also cross-platform. It works on Mac, Linux, and Windows. And it's using very native commands, things like list or upgrade or scale down at the bottom. By default, the command to set it up is going to set up 3 nodes or 3 servers for you. I want to move to 10 or 50 or 100. I can do that in one command with the agent count flag. So it's super easy to use as far as a management perspective. Without AKS, if you're not, and it's not only without AKS, if you're not doing a managed form of Kubernetes, you're responsible for the control plane, means that you're responsible for your master VMs, and you're responsible for your agents and for your workers. Over here means you're responsible for the hardware upgrades, the canonical upgrades, the system management. You're not going to have that easy upgrade scale. You can't manage things the same way. But with a managed service like AKS, we take care of the complicated work, leaving you to just focus on the nodes and the servers themselves. Now, as powerful and as amazing as Kubernetes is, there can be parts that's simple. You can also end up getting very, very complex and having very large workloads. That's where release automation tools come in, and that's specifically where Helm comes in. Helm is the package manager for Kubernetes. It is the best way to find, share, and use software that's distinctly built for Kubernetes. You can manage complexity through what's called charts. You can easily update, and you can do rollbacks in the event that you push a release out and then you decide you want to go back to a previous version using one simple command. And that'll also roll back any infrastructure. It'll roll back to a previous image as well as anything else you define in your chart, which can include architecture, things like Nginx Ingress controllers, getting down into web server management. I'll show a brief demo of that. And you can also simply share your charts as well. So you can have private Helm chart repositories or public, and you can package them up as tarballs to make them distributable for cross-team collaboration. Helm charts essentially help you define, install, and upgrade, like I said, even the most complex applications. So you can even tie in your CI to that, or your database, or your services, or your load balancers. Again, all the architecture that we would have to manage individually, manually, we can now streamline and have bottled up as part of a chart that's essentially a declarative, templatized language. It uses YAML. So now we're going to quickly go into a quick demo. So I'm going to switch over. And by the way, everything I'm demoing, my slides, even the code to get started, even a demo code that I'm going to show you in a second, all of that is already available on GitHub. You'll see a link to that at the end. So first off, to get started with Helm charts, there's at hub.kubeapps.com, there's just a suite of charts that are already managed for you. They're considered stable charts. Again, kind of think of this like Homebrew. It's like Homebrew or apt or pit. So the same way I could go and type in, which by the way you can do if you want to get started with Helm, brew install Kubernetes-Helm. You could do that right now, and that'll install Helm on your system. There's a little bit more configuration. Of course, Docker's awesome. There's a little bit more configuration you would have to do to interact with your server. But the same way you would install that and it has a prepackaged stable version, that's what Kubernetes Helm Charts are. So I have a Jenkins Helm Chart right here. How many people in the room from maybe a CI/CD process are familiar with Jenkins? How many love setting it up and having to go through manual configurations? Wow, okay, that was more than I thought. So obviously it's super complicated to set up. What if I told you I could do it in one command? Pretty interesting, right? So let's take a look. I have what's called a values file. This is, like I said, it's YAML. So I'm using the stable release that I just showed you on Google to set up all my plugins, down even to my DNS name, all my Kubernetes cluster. I have an Nginx Ingress controller. There's a blog post about how to do that as well. But I have a hostname set up. I have an Ingress controller that I'm referencing in this YAML file. I'm even creating a secret. Secrets are where you store credential information, but it doesn't leave it public. All of this doesn't matter that you can see the name of it. It's getting encrypted and stored in Kubernetes. And I'm even telling it to use TLS, and it's going to set up my Jenkins instance for me. Now, all I have to do, I'm going to show you. I'm going to bring up my terminal. By the way, I do have a very customized terminal. The dot files for that are also available online. But I have a few commands here. So down here at the bottom is going to be my Helm command. This is where in one command I'm going to install a Jenkins server with all my plugins. Even, what I didn't tell you, is by me setting up TLS and actually referencing an Ingress controller, I have a Let's Encrypt Helm chart listening on my Kubernetes cluster. So it's even going to automatically, through this deployment, assign an SSL certificate. I don't have to do any of it. So again, removing all the manual stuff. So all I have to do is run a command for upgrade, install. I'm going to specify a forced flag that's just my own personal preference. We talked about namespaces earlier, where I'm going to name this. I named it Jenkins MDOYVR demo. Right here is where I'm specifying that file. I'm specifying the release name, and I'm telling I want to use the stable Jenkins instance. And all of this, again, like I said, is available online. So let me go ahead and hit arrow over, and I'm going to hit enter. This is going to start the deployment. One command, it's going to go through and set it up. So you can see the release doesn't exist, installing now. It gives me a little bit of notes, which make it a little hard to see on this big of code. But I didn't have to specify a password. It's telling me to type out printf kubectl get secret. It's going to give me the password that's needed for this particular instance. Now I can also hit enter here for my above command, and all I was running was a watch command on that cluster. I can see that right now it's pending. 25 seconds ago, it's starting the deployment. One command, it's going to set everything up. Now, let me, because this will take about 5 minutes to run, and we don't have 5 minutes to sit there and watch paint dry, I'm going to actually do the print command, but I'm going to I set up about 2 hours ago, the same exact script, same exact file, just a different namespace and different name of release. So I'm going to get the password for that. I'm going to copy this over. And I'm going to go to my Jenkins instance where you can see fully secured SSL. It's a real SSL certificate, not blowing smoke and mirrors. And it's asking me to sign in. So I hit admin. I paste the password in. And I'm logged into my Jenkins instance, complete with all my plugins already installed and configured. One command. That's the benefit of charts, even down to the networking and architecture that I have to do. Now, that's great in practice of setting up things and setting up my infrastructure. But how does it work in a full pipeline? If we're talking about the full end-to-end CI/CD, I have my build, I have my unit test, I have Selenium running, I want to get it out into release. How do I do that? Like I said, I like to use CodeFresh, particularly because of how simple CodeFresh makes it. I can still use infrastructure as code or pipeline as code. So down at the bottom, this is my repository. This is the same demo I used at a different conference 2 weeks ago, which was called Swamp Up. But I have all my credentials already added in. I have any variables I need. This is actually for my Selenium test, which is why browsers are in there. I scroll down to the bottom, and my workflow and pipeline is YAML, which is also in a public repository. So you'll be able to see the 178 lines of pipeline code. But let's take a look at one of the builds. So I just ran this like an hour ago, and I updated, there's a Croc Hunter game, and I updated it to lasers. So if I click into this build, I can see everything that it did. It built my Docker image, it pushed it to Artifactory, which is my Docker repository through JFrog. It even packaged the Helm chart. It deployed with Helm. It tested the image. It even ran my Selenium test. I can click down and I can actually see all the tests that it ran. It gives me all this information. If I go over to the game and refresh this, I can see that the game is working. Right now it looks like I am on the JFrog edition. And if I zoom in, I can see the commit ID, which is the latest commit that I had used for that particular edition. If I want to go back, I mentioned that in the event that you deploy something and it fails and you want to revert, you can go back. I'm going to show you the release in a second, but you can see the demo release that I just did 3 minutes ago while on stage. Here's the release I did 3 hours ago prepping so that you could see the Jenkins stuff. I can see all my Helm charts in a visual GUI rather than having to do it from command line. But this is the one I wanted to show you. 2 hours ago when I was testing it, I reverted to revision. You have release markers, so I reverted to revision 51 to roll back to the JFrog edition that you just saw. And you could see that easily because it says JFrog edition right there. Now, if I click on history, I can see where I rolled back. But what if I want to go back to the release that I had before, where my croc hunter got to shoot lasers, because that was cooler? All I do is I hit this button over here for rollback, which initiates the Helm rollback command. This just gives me a GUI to explain it in short time frames. But essentially, all it's doing is running these commands against my Kubernetes cluster. I'm just using a GUI CI/CD tool to automate this experience. So this is running right now. I can see everything it's doing. I can even see the information. If I hit info right here, I can watch as it rolls back the entire release to the previous revision. So this will take a handful of seconds, which it says it just completed. I might have to refresh this a few times while it's rolling. So it says the release was deleted, roll back, we'll refresh real quick. And by the way, this is the YAML file. Like I said, it is public online. There'll be a link to that. But let me refresh this one more time. And there's a previous release. So if I zoom in, we can see the commit ID changed. Zoom out, hit start. Now I'm shooting lasers. In a matter of seconds, I can revert back to complete previous revisions. That includes the Docker image. That includes any of the infrastructure, the architecture. If I had a different Nginx or DNS name or anything that I defined as part of my templates, I can immediately revert back. That's kind of the power, and that's a very quick overview. So let's quickly go back over to my slides, and we'll wrap up. And I do have a more in-depth that explains this a little bit more, shows you a lot cooler things. I have a ton of different recorded sessions of that online, or you can come find me. I'll be here through tomorrow, so midday tomorrow. So you can come find me and ask me more questions. But let's talk about kind of what we just saw. Aside from the Jenkins thing, we had code that lived out in GitHub. I have a Kubernetes pipeline set up in CodeFresh. It handled the build. It handled the package deployment. It was able to deploy it out to Kubernetes in Azure. I was able to tie in Selenium tests. What you didn't see running in the background is I even have JFrog X-Ray listening to that repository in Artifactory that was doing vulnerability scanning. And for my Kubernetes repository, for the vulnerability scanning, I had Artifactory and X-Ray tied in. So from a systems administration perspective, I'm able to tie all of this in. I can set it up to where my developers are using Kubernetes on Mac. They can use tools like Draft that will actually detect the language they're coding in and set up their Helm charts for them. Check it into source control, then we as IT can go in, look at those Helm charts, and add in our DNS information or our Nginx information or any other changes that we want to make. If we want to do, what was it? I'm blanking on the name, but there's additional configurations we can do. There's somebody that reached out to me online and they wanted to make additional configurations in their Helm chart. And you just update the annotations as part of the chart, and then the developer doesn't have to worry about that. They can code, but you can work on the architecture and infrastructure. So thank you very much. Again, like I said, the resources are available online. So there's actually a gist that you can go in and see all the links to everything. You can even get started on Azure with $200 worth of free credits. You can go to aka.ms/DevOps/K8s_Helm. And then if you have any questions, again, you can find me pretty much anywhere online at JLDeen. Or you can always email me, jessica.deen@microsoft.com. I will say I'm not super responsive on email because I'm usually traveling, so Twitter's usually best.